Hey everyone, Steve here in the Apollo Division at FRC DCMP here at 5431 Titan Robotics, a dark horse for this division, and I'm really excited to walk through their amazing robot. They have a handoff system for their intake for their 2 shooters on one robot, and also an amp mechanism and climb mechanism. Really excited to get down here on Behind the Bumpers.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
Cyrus, talk to me about your drivetrain. It seems like you guys are using SWORD, but you also have underneath the bumpers electronics. Talk to me about that.
Yeah, so our drivetrain is 27 by 30 inches. We're running Mark IV swerves with Kraken drive and Falcon rotation on L2 gears. So we're using L2 because that's what we had, and it gives us some extra torque, which we can afford with Krakens. The reason we're using Falcons is to save money and to lower our total weight. So the most interesting thing that I really like to do about our drivetrain here is our under the bumper electronics. So when you look at our robot, you might notice that our Rio and PDH are nowhere to be seen. However, when we go down here, you can see that both our Rio and PDH, etc., are mounted underneath the robot. This allows us to save space because of how we're doing our other mechanisms.
Yeah, let's head off to Imanol. Talk to me about the intake you have. How many iterations, design changes, what happened throughout the past season?
So firstly, our intake, this is version technically like 8, but it's mainly just changing these base plates right here, as well as small changes in these. So the really big changes ever since Plano and Dallas are we switched these plates to 1/4 inch from 1/8 inch because we had some durability issues during Plano. And you'll see that a lot of the iterations we make here we're trying to make the robot more robust in general. So we switched from using a belt on this pivot to a chain and sprocket. That gave us a lot more rigidity there. Again, this is 1/4 inch, this is 1/4 inch. And obviously 1/4 inch is about double the weight, 1/8 inch. So we had to pocket it here to make it a lot lighter. So there's a lot less work on this Neo and we can gear it down as much as possible.
And I see you guys also have an amp mechanism that basically looks the exact same. Talk to me about that.
Yeah, so the idea was take everything we learned from this intake and apply it to this amp mechanism, which essentially bridges the gap between our intake and amp, and it's another handoff. So, yep. So we have, again, same as the intake, polycord. We have a twist right here, so they switch directions. Using the exact same rollers, polycarbonate panel, exact same chain pivot. Everything is essentially the same, except for these are 1/8 inch, since they're not seeing as much impact as we saw in the intake.
And can we see the demonstration of the handoff?
And as you can tell, we're going for simplicity in this design.
Now, that is a perfect transition as your handoff. You guys have dual shooters. Tell me why dual shooters?
So on our version 1 of our shooter, we had a singular version of this shooter. Now for our version 2, we decided we wanted an angler so that we could score from both the subwoofer and the protected zone and maybe further. But we did iterate that, and what we found out at Plano was that the rigidity of the angler was really, really bad. So we backtracked and decided that, well, our version 1 works really well, and that we still want that lower angle to be able to shoot from a further distance. So back down here, we have a lower angle shooter that serves as our second shooter.
What are the 2 angles that you guys have for both the shooters?
So we have this top angle is about 55 degrees relative to the intake. And then this bottom one is 35 degrees relative to the intake.
Now, how reliable has it been with 2 shooters? Is there any power issues or anything like that?
No, we only run one at a time. So we don't have any power issues. So it's the same power draw, even though we're using 4 motors. We have had some issues with resonance being really weird. There's like one bolt that just like you can't screw it in all the way, otherwise the resonance is messed up. But that's just a weird quirk.
That's fair. Now let's head it over to Nathan. Talk to me about your climb that you have. It seems like you guys have a locking mechanism. Kind of reminds me of Rapid React, but tell me more about it.
Okay, so our climber, it begins with a completely different system. Initially, we had 3 pieces of 2x1 tube stock and a single one in the center that would go up and down. That was terrible. It didn't have a hard stop, it was unreliable, and it was very, very heavy. So essentially, after Dallas, we decided, how can we redesign this? And we took this, so we made it a single tube, 1x1, double hooks mounted to a chain tensioner on 2 sprockets, which is driven by a vortex, 1 motor on each climber, and that brings it up and down. Can you show it? So yeah, it's currently still having, I'd say, some issues, but it works pretty well so far. The hard stops are a bit iffy sometimes. However, at this point, we have increased the gear ratio so that, depending on it might be able to work without the hard stops. We don't know. We haven't tested it yet. Yeah.
But I assume this is kind of spring-loaded.
Yes, it uses surgical tubing, which is connected to the bottom with some zip ties.
And so when the chain gets down here, are you guys able to hang?
Yes.
And you guys just float?
Yeah, basically.
Now, that gives me a question, which I'll hand off to Chris. If you guys get a note stock in your robot, because there's kind of some open space, you guys have a system apparently. Tell me about that system.
Yeah, so throughout all of our qualification matches at Dallas and Plano, and as well as our practice matches at home that we were running, we were finding that we were getting a lot of notes stuck in our robot, which would then put us out of the entire match. So we've had multiple different systems that we've all implemented into the robot in order to stop that from happening. The main one's in the middle of this robot right here, where we have these surgical tubes that are all interconnected with the polycarb in the middle. That way, if we have a note that falls into our intake, it's able to simply slide out from the front by the intake from our driver and operator just spinning around on the robot.
That's actually a smart move because you have open space over here. Might as well get out the note so you don't have to deal with those penalties.
Absolutely. But this wasn't the only place we were seeing notes get stuck in. If we go towards the shooter in the back, we were noticing that if we had missed a shot into the speaker, that the note would slide down the subwoofer and into our shooter area. So what we ended up choosing to do is taking this piece of polycarb and just dual locking it onto the back so that a note couldn't get stuck onto it, and we would be able to just drive away and have it fall on the ground.
Finally, I want to hand it off to Natalie. The handoff system that you guys have with your amp mechanism, your shooter mechanism, tell me about how your intake is being able to pivot so accurately.
All right, so we have an absolute encoder mounted on the actual shaft that the pivot moves on. We used to have it mounted on the shaft that the 1.1 was spinning, but that produced a ton of inaccuracies. But after we switched to the shaft, it's much more accurate. In this, we have it also working with a beam brake so that as soon as a note gets into our intake, we pivot up and get the note into our system.
Are you able to see that in motion?
Yeah. No, our default pivot system is directly above or under the amp, so that way we can feed into the amp without having to change much at all. But if we take another note, we automatically change our pivot set point based on which of the shooters is running, so that if we ran our top shooter, as you can see, it pivoted down all the way there, and the bottom shooter. Something else we have with our shooters is signaling to our drivers. So when we're all the way ramped with, say, the top shooter or the bottom shooter, our lights go green, and the controller, operator controller vibrates so that they know that the shot will make it.
Well, 5431, thank you guys so much for taking the time to walk us through your robot. Thank you, Frank, for also operating the robot as well. What an amazing robot. You guys are one of our dark horses for this division, and you guys are currently ranked 10th. So we're really excited to see how well you guys do for the rest of the event. Good luck, you guys, and congratulations on a great success.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.